concerned about that compared with what we've done already?
I mean, you're right there.
I'd say they're immunized.
They're just collecting all these different things and being like, are we sure these should be...
But, okay, not gonna lie, that's earlier in the recording than it normally is. So, like, to start off a class by
Right.
saying that.
So here's the question for those of you at home. The answer is no, because you need two objects, not just two forces on one object. You always have to have two objects acting on each other.
Hi, Ender.
You're not here? Can you pop back up the question?
Yeah, sure.
You have to pop it.
Yeah, pop it.
Make a popping sound or something.
Everybody make this with.
I love AP physics.
This
I
is
thought you hated it.
That's what this class is? Ah.
AP something.
So it's not just insanity.
See, that's what I thought it was.
Yeah, I thought this was nap time period. Oh, sorry, son.
Once you finish with that question,
I actually do this.
She does.
See, you can tell your kids they're not gonna have Christmas.
I often do this, and then it becomes this, and then it spreads.
Yeah.
Yep, I do that too.
Yeah.
So it's
Me
like,
too.
Don't.
No.
The
Oh,
I think you do that wrong. You do that wrong.
we're halfway.
Because it's slanted.
we got a box on an incline.
No, we
Woo!
Mr. Hathaway, I think you were just standing on an incline and you were drawing wrong.
I think I sucked in too much helium today in physics class. I got a little bit left. We'll see if I can use it at the end.
Okay, the way that you said that though, you kind of like were a little bit
Little bit
slurred.
early.
You know, like, ugh.
He goes, hey,
These
go.
parts are good. Poor young
Good.
girl.
Heyo.
He says, I mean, her.
Is it left, right, or is it
It's straight into the point.
points?
The funny part is, like, no one ever notices what you do. No one ever thinks your voice high until you make it go super deep.
Right?
Oh, you got
That's one time I had helium from a balloon and it didn't do anything, and I was like, oh, okay.
No. You just gotta suck in a lot more. Until you pass out. I think I almost passed out once today already.
I have almost passed out with waking up for sure.
Strange thing happens when you replace oxygen with helium in your brain.
So
Really?
we were concerned that you hit your head yesterday, and today we need to make sure you don't pass out.
Let's just make sure you don't die of helium poisoning.
As a kid, I roughhoused so much that if there's one thing I know how to do well, it's fall. So,
Same.
Okay, you actually got me good yesterday because I literally looked.
I love seeing his foot come up. I could see it over the desk. Wow.
you can see what?
I can see your foot come up.
Oh,
and
really?
you're down. Yeah.
I was like, ooh, wait.
I was up
Who
high enough
broke
that I
their
could
foot
just...
or ankle in the NFL? What's the guy's name that we were talking about?
Dak Prescott.
As long
Yeah.
as it wasn't that terrifying.
My
So
parents...
yes, people in the picture, and you were wondering when this is taking place. Look at Dak Prescott breaking
Yeah.
his ankle.
No
There you go.
surprise, he was on my fantasy team.
Really? I think wasn't he on?
I get Russell Wilson every year, he never lets me down.
Nice. Yeah, he's good, because he gets a lot of touchdowns himself, too.
Dak Prescott. That's because I drafted a quarterback in my
Okay, so we gotta focus now, because we've got 3 examples we gotta get through, and this is where we're gonna start. We've got a block on an incline. If you remember from last year, when we're dealing with these force diagrams, we have to take the x and y axes, and we have to rotate them. We rotate them such that the y-axis matches with the normal force, and the x-axis matches up with the plane. And so that's what we have right here. We've got our different axes. So, first thing we want to do with this, before we even figure out what we're going to solve for, we want to draw it again. So, we've got force of gravity going down. We've got normal force going over there somewhere. And we've got our new axes as well.
This is static, right?
Yes. Or no, this is not static. This will be accelerating down that ramp. So this is our x, this is our y. And so, of course, what that means is we have to take into account the portion of gravity that's acting in the x direction and the portion of gravity that's acting in the y direction. In addition to that, we need to throw in some angles here, because it would be no fun without angles.
37 degrees.
So who remembers how we figure out where this angle goes?
Oh, you imagine where you could slide it.
Yeah, exactly. Is it going to slide to the left or the right? Perfect.
Dude, I remember that. Perfect.
So that goes there. Generally in math and science, when we have another angle where added together they'll equal 90 degrees, we use this symbol here. It's the Greek letter phi.
Oh, phi? I haven't heard that before.
Yep. And they just alternate as you go around. So they'll always add up to 90 degrees.
Wait, isn't that like the golden ratio sign?
Uh-huh.
I don't know.
That's how I drop theta.
Wait.
E5 photo.
Let me check. No, wait, is it phi or phi?
It's PHI. I say phi.
Oh, because you're saying that the one horizontal and the vertical add together to make 90?
Yeah.
Ayo.
So,
Is that what you're saying?
questions so far?
You like the Springmans?
Springman? Is that a musical group?
Yeah, they come here every year.
Oh, them. Oh, yeah, the taco people.
Yes. Yes. Chimichanga.
Oh, chimichanga, that's what it is.
Yes.
Okay. So, all the forces in the x direction, when you add them up, that's something that we're going to have to look at. Same with the y direction. So if we're looking in the x direction, we've got FGX.
Oh, phi is the golden
I
ratio
think so.
symbol.
Okay.
And that's going to be equal to MA, because there's nothing else going on here. There's no friction. So whatever this force is, it's going to be equal to mass times acceleration. Keep in mind, this acceleration is the acceleration along the plane in the x direction here. So, if I want to solve for FGX, I can do that. So this is the adjacent side of phi, that angle. So that means FGX is going to be equal to FG cosine phi. And that's equal to MA. Of course, force of gravity is equal to mg.
MT. What songs did MGMT even do?
And look at that. We weren't even trying to solve for anything, and we actually ended up solving for acceleration. How about that?
So gravity cosine phi is equal to acceleration.
So that's how fast you'll be speeding up going down this incline without friction.
Great job, Mr. Hathaway.
Thank you.
I mean, what?
That's right. I mean, thank you, Placido.
You're welcome.
So in the y direction, we got normal force and we got FGY.
Why are you shaking your head disagreeably?
So normal force minus FGY. Is this equal to MA?
Yes,
No.
you wrote it.
It is! But the acceleration is equal to 0 because it's not moving in the y direction. It's just moving in the x direction.
So it's
So
all
it's
0?
equal to 0?
So they're equal to each other.
So that means 0 equals Fn minus Fdy. So Fn.
Yeah. So typically, remember from last year, we oftentimes had to solve for normal force. And it's usually equal to whatever FGY is. So FGY is over here. It's part of this triangle. And we've got our angle theta. So it's the adjacent side to that angle. So I'm going to use cosine.
So it would be Fg cosine equals Fgy. I mean Fg cosine.
Yep. In other words, mg cosine theta. So that's equal to your normal force here.
Mr. Hathaway, this is some tea.
Any questions on this?
I think we're
Now, yes, question somewhere?
I don't know. I'm just leaving it open for people who might need it.
So, I use cosine just because that's what I find easy. I know this arrow's going this way and this arrow's going that way, so I just use those. But maybe you're the type of person that only wants to deal with this triangle.
Yeah,
That's-
what I was talking.
Yeah, that's totally fine. So then, instead of writing mg cosine theta here, you would be, this side of the triangle. So that would be mg sine of phi.
That would be FGY, right?
Yes.
Yes.
So that would give you the exact same answer if you want to do it that way.
For 5 hours.
Now, knowing all this, let's say we want to calculate a couple other things.
Can I find the meaning of life? So that's okay. Well, I'm not going to come at you for that because it is kind of funny, but I mean, what we do. I know.
Let's say we want to solve for the time after the block has gone a certain distance x.
Wait, I actually don't know how to do this. Or I
But
don't
you
do
do.
this. I just don't remember.
It's kind of small. It says solve for t after the block has gone a certain distance x.
And that's not practice.
It starts from rest. So in other words, this block has moved a certain distance down that incline. And I want to be able to calculate how long it takes to get to any of those positions. So I can do that just by using this equation.
So then we have to solve for acceleration.
Yep, we got to solve for time. Now, original position is always 0 unless someone tells you otherwise. And we're starting from rest, so that's gone too. So x equals 1/2 at squared. This a is not negative 9.8 because this is the x direction of this equation. This is the acceleration going down the incline. This isn't a free fall. So we did solve for that, and that's going to help us out a lot. First, I'm going to solve for the t. So multiply both sides by 2 here. So we've got 2x over a equals t squared, and if I get rid of that squared, I got to take the square root of both sides. And of course, we do know what acceleration is.
Mr. Hathaway,
Yeah.
could you say that it's 2x? Oh, that's what you were doing.
Yep.
I was going to say 2x over g plus 95.
2x over g plus what?
G cosine 5.
Oh, yeah. Yep. That's it.
That's what you were doing.
Absolutely.
Hold on, is this on our formula sheet?
No. This is something that you got to be kind of comfortable doing.
You gotta memorize it.
No, you're not going to memorize this. You're just going to be able to work it through. Now, one of the reasons I'm leaving these with just letters is because oftentimes in AP Physics we have to leave things in variable form. They love variable form on the AP test in the spring. So I want to try and get you prepared for that, those of you who will be taking it. The other thing is maybe we want to solve for the velocity at any position. So like maybe you have a spot 1 meter down that ramp and you're like, I wonder how fast it's going at this point. And you can figure that out even before you let it go. And that's what we're going to do right now.
Does that mean that we
So it starts from 0 again.
Yep, starts from rest. And if you're looking for the velocity, you should look for a velocity equation. We don't know how long it's going to take to get to any position. So I would look for an equation that doesn't have time in it. Hence, time-independent velocity equation. Original velocity is nothing. And of course, we know acceleration again, g cosine phi. And change in distance x, same thing as just saying x. And we want to get rid of the square. So that means we got to square root it. And so that's just a general expression for how fast you're going after you travel down that ramp a certain distance x. You plug those numbers in. A lot you can figure out with letters. Whew. Take a deep breath. We've got 1 or 2 problems left we got to do. We're going to do the same problem in 2 different ways. And this is the same problem that you guys had to deal with last year.
I don't remember how flex.
Any questions on this?
Is it a differential function?
At least you don't have to do any derivatives or integrals during this.
All right. So time for some u substitution.
I take it all back.
I'm kidding.
I was gonna say, where you use substitution?
The bottom.
And then
Oh, man, this rag is so much better than the old one. Hey, Jaden.
Hi, Sarah.
Hi.
Hi, Ben.
It's a non-
Hi, Ender.
Yeah.
Ender, you got a response tomorrow, otherwise we know that you didn't watch this.
Okay, can you make it where you can like make comments or like something, like
You
or
can.
like ask questions? No, I cannot figure it out.
School USP.
I know, but school university is fun.
This is called an Atwood machine. And we did this last year in the force section. And I'll give you a little bit of a refresher right now. That's a big refresher.
I
Not a little.
remember it.
Oh, good.
It's all good.
Which of these looks heavier, M2 or M1?
M1. I mean,
I'd go with M2. It looks bigger to
what if
me.
lower on the thing? You never know. You don't
It
know
could
how
be.
dense it is.
It could be. It could be.
But yeah, are they moving?
For these, I'll say M2 is greater than M1. So yes, then it would be accelerating clockwise. That way. Because this is clockwise, you know. So if we want to solve this, we got to treat these blocks by themselves. We've got M1, we've got M2, and let's see where this takes us. Okay. Now remember, there is one rule that you need to remember, otherwise you're going to start all these problems absolutely wrong. You'd have to start over. So remember this. Anybody know what I'm about to say?
That could be a
Words.
I feel like it's something that I really know might be obvious. Like it's gonna be something about a force diagram?
It does have to do with force diagrams. When you're creating your force equation for these masses, which force is going to come first?
gravity. Tension.
The force that's winning. Whichever force is winning the battle must come first in your force equation. So for M2, of course, gravity's winning this battle because it's going down. So I would say for M2, Fg2 minus tension equals Ma.
How do you know gravity?
Because I said that M2 is heavier, so it's going to be going down. So gravity's winning that battle. M1 is going to be the opposite. Tension is winning that battle because it's going up. And the next step in this big process is to get both of these equal to tension force. So we just want to isolate the Ft. I'm also going to change my forces of gravity because force of gravity is just mg. So I'm going to move this over there. And if I do anything wrong, just let me know. Perhaps. I never did that to you guys last year, did I?
This is physics. This is AP.
I won't say that.
I think I did that right.
That
is absolutely.
Yeah. I think I'm good.
Sarah will be letting you know.
So,
Sarah.
Yeah.
this was step 2 in that big process to solve for tension force. Now, because tension force here is the same word as tension force here, means these equations are equal to the same thing. So you can set them equal to each other. Hi.
She's taking your physics class.
Oh, wonderful. You're welcome to come in if you like. Whatever. See you later.
Who's coming today?
New student.
This AP.
I don't know, actually. If that was for this year or next year, I don't know. We'll find out.
What's going on?
We don't know.
Okay.
And who is this?
All I know is tension is equal to both of these things. And if I want to solve for anything, I'm probably going to have to solve for acceleration. Most often you're going to have to solve for some sort of tension force. And to get that tension force, you got to know how fast this whole thing is picking up speed. So if I want to solve for acceleration, I want to get these A's on the same side so I can factor them out. So I'm going to move this over here, and I move that over there, and make sure I do it right.
Hey, they had this in the book.
There we go. Yeah, this is
proud of you, Rod.
one of the examples, yep. Okay. Okay.
Why is this right?
Oh, okay. I was confused. Why you write the same thing again?
Yeah.
I'm 1 over M2 plus A2 over A1.
That's not funny.
It is incredibly funny.
Very funny.
Are we even talking about it?
I don't think we're talking.
I don't know what's going on.
Okay. How do you feel about that?
It's kind of differential.
I think I get it.
Look at all those letters.
Magma.
Wait.
Mama.
That's all.
And this is how magma works.
Oh my
Did you,
gosh.
Mama's
Sorry,
good.
do you have a different
And then-
direction of
And then you take the derivative, and you get lava. Lava is just the derivative of magma. Who would have thought?
Bro!
Rock.
Water.
No, wait, Seth brings up a valid point. It's the integral of magma.
That is a good question, and I don't even know that.
No, it's
You
a
gotta-
good point.
Brock.
You don't know like the real thing. Wow.
So that's your acceleration. If you wanted to then solve for tension force, you would take this piece of madness and you would throw it in right here.
Okay, but when there's numbers, it would be easier.
Yes, it would be.
Condensed.
Yes.
It's so ugly.
Oh, I don't know. It looks pretty adorable to me.
If that was an
Aw.
angle,
The face only a child.
It's just because it sounds like a baby. Mama, what's this, Mama?
Mama.
So yeah, you would
It
get
does say mammal.
M2G minus M2 times that. That would be your tension force here. And this was the same process we learned last year. Now this, I would probably say it's easier to follow this procedure, but this procedure is a little bit extra work than we might need to do. There's another process that's, I would say it's shorter, but there's a lot more ways that you can mess it up, which is why I don't teach it in regular physics. But I'll show you guys. And then you can do it however you want to do it. No!
I'm really gonna mess it up.
Final questions on adorable
I'm already
letters.
On magma.
You're confused? What are you confused about, Potter?
Nothing.
Good.
That's
what I
You know
thought.
what you should do?
Yes.
You should have the camera conveniently cut out for this second play.
I have a lot of questions, but
Oh,
I'm
right.
afraid if I ask.
It's like this one video that I saw. It's like
I'll make fun of you
God
and
wants
stuff.
you to love you in everything you do, and the way to do
Oh,
that
Connor, we can't make fun of you anymore.
is it's just like
Oh,
a loud music track.
You know the conversation we had.
Mr.
Connor
Fisher.
isn't the foreign student. We're all convinced.
What just happened?
It's just in a minute.
Connor, you don't qualify as a foreign student.
Yeah, sorry.
You're just a student.
Why?
Potter, no!
Where's Connor going?
Placido.
Good riddance.
You guys remember?
You go find him, Placido.
We should all hide.
Mr. Hathaway,
Let's all
why
go down to
does
the
physics
staircase
exist?
level. Let's go then.
Well, physics is the world. In essence, we are the world.
We are physics.
If you try, what if a simulation inside a simulation that's run by simulation?
This is going to comparative origins, so let's not.
Where's Potter?
Guys, weren't we just talking about Trevor?
I don't know what we were talking about. Trevor. You brought trouble.
Trevor knows where to go with his outer way.
Share Trevor solve this.
Ooh, yeah,
right.
Trevor's magma.
So we're gonna do this again,
Lava.
Again? No.
but a different way.
Yay.
So,
No.
remind me again, which comes first, the force that's winning or the force that's losing?
We like to win first.
Force that's winning.
It means it's bigger, so you
Trevor,
subtract
I'm
from
gonna
the
solve
bigger
this.
number because we like percent.
They're the same thing. Oh. Yeah, they're the same thing.
So far. But will they stay the same? No.
They will.
It's a different way. He's gonna switch the variables to Z's and W's instead of.
All right. So there we go. This is the same equation that we had before.
You're gonna solve by acceleration.
And again, we should solve this for tension. I wish I hadn't erased it, but whatever.
So can we use either way, or we
I
have
mean,
to?
I meant to do that. What's that?
When we're solving this kind of problem, can we use either way?
Yes.
Okay.
P's and Q's.
Mine's
So far it's the same.
Mr. Hathaway, I don't know if this is actually different. We're just pulling one up over us.
You never
Anything
know.
else?
The entire AP Physics is just him messing with us.
I mean,
The last day of class, I'm just gonna be like,
Okay,
This
here's
isn't
what we're
true.
actually supposed to learn.
yeah.
so
It's like you have 24 hours.
Yeah.
Here's how crystal balls work. That is
Huh?
how. That is the one thing you should be learning from this class. All right.
What?
That's the helium talking again. Sorry.
Please.
Okay. So, if we want to solve this in a separate way, and some of you guys had this. Did I do that right?
Yes.
Okay, good. Some of you guys kind of had this gut feeling last year, and I could tell because I was like, "These guys are going to be in AP Physics next year." Yeah.
This handle, like,
You broke my handle?
plants drawer.
Placido.
Actually, I don't even know what's in that. I've never actually been in
Nothing's
those. Okay.
The handle just.
Can I put stuff in those things?
So- The one way.
No, it's like.
Back up here, guys. Back up here. A little bit longer.
Back up there.
So these two masses, in the previous example, we dealt with them as they're kind of separate. And we dealt with them separately, and eventually, we got their accelerations and their forces. But last year, what I remember hearing from a lot of folks, which is absolutely true, can't you just treat this as it's like a battle between these two instead of treating them as separate masses? And you can.
What's this greater than symbol?
Your net force is equal to mass times acceleration. So what is the net force here? You've got this mass, and you've got this mass. And just like previously, we have to put the one that's winning first. So force of gravity 2 is winning, so that comes first. From it, we subtract force of gravity 1. And this is the part that, when I would teach this to regular physics, this is the part everybody would mess up on, so I just stopped teaching it this way. This M, what do you suppose goes in here?
M1 times M2.
M1 plus M2. Because if we're looking at the entire system, we have to take both masses into account. So this is going to be M1 plus M2.
Why was that so hard for them to understand?
I don't know. It was the small mistake that showed up every time students would try and solve it this way. So,
So I would rather use the.
you like the first one better?
I like this one.
I mean,
So yeah,
Haven't finished yet.
this one would just be
Is there like 13 more variables that are about to come in? Otherwise,
M1G equals that. So your acceleration is just this divided by that.
Well.
it's all funny. You can proof. He's halfway down the field.
Well,
Well. If it isn't Ratchet and Clank.
I gotta get that stairway carpeted.
No, it's very similar.
Same exact thing.
So it's the same exact thing. In my mind, this is less work. And I kind of like the idea of comparing the two masses and the forces directly. Instead of doing all those equations and setting all those equations equal to each other, I feel like this is less steps. So then in order to get your tension force, of course, you take your acceleration, you plug it in here. Or if you really like tension force 1, you plug it in here. And then you get your tension force out of that. And that's force. So let's get a little vote. How many people think the first way is better and easier? Raise your hand.
Honestly, they're the same.
No, this is the same stuff.
How many people think the second one's easier? About the same?
I have no idea what
Same.
to do with it either. I have problems
Okay.
between.
Easier because it's short.
Because that way you just you have a common thing that you have to
Right.
force of tension. Then you just combine two together and take out the common denominator.
Right. It's very procedure based. This one you do have to do a little bit of interpreting. You got to make sure you know which of these is going which direction. You got to get this order right. You got to make sure you don't forget about the two masses. But yeah, and there you go. That's all I got. Yes.
Why don't we study 3s, 2s, or 1s?
What?
Why don't we study 3s, 2s, or 1s? Why only 4s?
Well, we would, but we run out of time usually by the end of the year. We can do that after the test.
Alright.
All right.
I was so confused where you're going.
I wonder.
1.
Yes.
All right, I got a little bit left.
Oh, girl, let me get some.
Okay.
Hey, no, we don't have
Stop
to.
COVID.
Well, I've seen them, but I don't use what's in there, so it's been a long time.
You couldn't do this with a COVID.
Oh, there's a body in
Yeah, I just had to do it myself.
Aw.
So I have ingested 2 balloons worth of helium today.
Go ahead, Mr. Hoffman.
There's not much in here, so it won't last very long.
It looks like a third. It's like the white stick. It's like the all white.
Don't lean back while you're.
It's like a
It's a beautiful day in the neighborhood, a beautiful day for a neighbor. Would you be mine? Could you be mine? It's a neighborly day for a beauty wood, and now it's already gone. I wish I had more helium. You can still hear it a little bit.
Yeah.
What theme is that?
That's Mr. Hoffman.
It's Rogers' neighborhood.
Mr. Rogers' Neighborhood, absolutely.
Yeah.
So,
they made a spin off of that. It was like Daniel Tiger's neighborhood.
oh yeah.
Yeah, my sister wanted that.
Yeah. Have you guys seen the updated Tom and Jerry? I hate it. That's a thing. They
Have you
talk.
seen the update?